Alright, so far we saw the intuition behind these different combinations and permutations, right? We manually wrote down all these scenarios. But from this video onwards, we'll see how do we derive the formulas to directly get the number of solutions rather than writing all the combinations on the page, right? So we'll start with the first one, which talks about repetition is allowed and order matters. Let's start with an example with little more complexity, which we saw in earlier. Right. So this time, the question is, what are different ways of selecting and arranging 2 out of 4 alphabets? Last time we had 3 alphabets. Now we have increased it to 4 to make it more complex and probably getting a better understanding of it. Right. So we have to find different ways of selecting and arranging 2 out of 4. Given that repetition is allowed, which means we can use AABB and order matters. AB is different than BA, so both of them can be included, right? So feel free to pause the video and guess your answer yourself. So make sure you don't write these values once again. The idea is to come up with a formula yourself to get to the number of solutions. So you can pause the video and try it yourself first. All right, we'll talk about the solution now. So let's review the problem first. So we have 4 different alphabets to choose from. That is A, B, C, and D. So these are the 4 options we have to choose, right? And we can only choose 2 out of them. Either we can select A, B, C, D, A, C, A, D, or A, A, B, B. Right? So these are the few choices which we can make out of these 4. Now, if I choose first position A, so if I started with A, let's select A as the first position. Then for the second position, I would have 4 candidates. I can go with A, B, C, D, right? So it will give me a combination like AA, AB, AC, AD. So for first position A, I will have 4 possible options. Similarly, if I go with B, then I will have again these 4 options. I can go with any of the combination. As similar for C and similar for D. This is how we can create combinations, right? So you can see that depending on the starting position, I would left with some options in the second position, which means we can fill position 1 or first position with 4 choices, which is either A, B, C, or D, right? But for each selection, whatever it is, we still have 4 choices for the second position. So again, it's a grouping, right? With the other rest options. So hence total possible number of solutions will be 4 multiplied by 4, that is 16. First position can be filled by 4. Second position can also be filled by 4. So this will give us 16 possible solutions. So to generalize this formula, we can say that if we have to select k elements with different arrangements from a set of n elements such that repetition is allowed and order matters, then that would be n into n into n k times. That is n to the power k. So this would be the solution for such kind of case. Right? Let's look at some sample problem. Probably you can try solving it yourself also. So let's say there's a deck of 52 cards, and the question is, what are different ways to draw 5 cards out of these 52, such that you draw these cards one by one and keep them back again. So it's a with replacement, right? After noting down the card face value and order better. So can you tell me uh, how many combinations you can create out of it? Make sure you don't write all the combinations. Probably you can think of, if you have 5 places, how many uh, how many time what are the different options to fill each of these positions, right? So the solution would be, since each draw will have 52 available choices available, right? Total number of different ways to draw cards with placement would be 52 to the power 5. Cool.